Hey everyone, today I'm going to be welding this piece on the bottom of this Dodge bonnet, or hood if you come from the other part of the world. And the bottom section on here was rusted away, so I've made a new piece and I'm just going to run a weld through here to tie it all back together. And today I'm using oxyacetylene. Now, you could use any kind of weld for this. You could TIG weld it, you could MIG weld it, but today I thought, old school project, I'll do it with the oxy, we'll do it in an old form way, and it'll be a good demonstration. Now, we're going to curl it up a little bit. We'll have to work it as it goes. So it'll be a little bit of welding, stopping, tapping and working with it as we go along to keep the panel flat. So it comes back down to that whole stay in control of it all the time. So don't be surprised if it buckles up. There is already a little bit of tension in the panel from where the louvers were pressed way back in 1924. And that was held in check by the bottom piece on the panel. And once I've cut that off, it's just allowed it to wobble around a bit. So as I tie it together, that will flatten out and the heat I'm putting into it will help sort that out as well. So settle in and we'll get into it. Now when welding and doing this sort of work, you need everything to be within easy reach because you're going to be swapping from the welder to the hammer and dolly and back and forth. So you need to be able to reach everything quickly and easily. Now I'm using a very small tip. This one's a number 4, and what I'm after is a neutral flame. So you see the little feather on the end I'm just bringing in and out. When that comes down to being just gone, that's neutral. Equal amounts of acetylene and oxygen, and that's what we weld with. And we want about that much fire. Now the plan is to just weld the two pieces of metal together, but I've got a piece of wire here just in case we blow a few holes in it. And it's been a while since I've welded like this, so I could be a bit rusty. So we'll see how we go. Now, I treat this like any other welding job. I'll do a few tacks and then we'll weld between the tacks. But you really need the panels to be touching for it to just melt together. With oxyacetylene, you just got to work the pool of weld all the time. So we're just bringing the metal up. It's starting to melt now. We've got a tack. It's just flowed together like that. That's the expansion in the metal, making it creak a little bit. And there we go. Previous tack's just cracked through. I'll just run a bit more weld on that. Oh no, optical illusion. Alright, just work the puddle. That's done. Now we need to make sure our two pieces of metal stay sitting together. Now the problem we have, as the metal gets hot and expands to be welded, it also gets soft. And soft metal is very malleable, so it has cracked the weld this time. So when the metal expands out, the metal around it actually shrinks because it's being pushed in there by the section in the middle that we're working with the weld. So that's where the problems come in. Just get a little puddle on each side and then flow it together. That's got him working. Righto. Now I've ground both sides because the paint will contaminate the weld. And if the paint burns around it, it will load a bit of carbon into the weld area and make the weld a bit weaker than what it could be. Screw the little weld puddle. That fire has gone a bit oxidising. See the little sparks? It was just starting to burn the metal a little bit. So we'll grow the puddle. Just push the puddle along in front of the fire. Now pulling the heat away stops it from burning a little hole in it, and that's entirely experience. When you start looking at the puddle and thinking to yourself that any second now this is going to want to collapse in a puddle, time to pull the fire away. So just try and stay in control here, keep it sitting together. Now I've got a situation where, because of the shrinkage around the weld, I've got a little overlap. So I'm going to work that out by just stretching this weld area in here. So hammering straight onto the dolly will stretch that area and work that little overlap out. Now the panel's opened up ahead of me, and that's because I'm heating it in here, so I get this leverage effect on it. But as it cools down, this gap just closes in. Just loosening the two clamps off up here, so that it will actually slide through between them. Now, I'm not really worried about the shape of the panel at the moment, because naturally hot metal is bigger than cold metal, so it will do its own thing a little bit behind the weld, and then we'll just go back and sort that out as we move through the panel. Just make a little puddle, make a little weld with it, come back, wet up the little puddle again, get him moving. I'm just going to push the little puddle along, and it's just fusing the two pieces of metal together. Exactly the same technique can be done with a TIG welder. The only difference with the TIG welder is you can control the temperature of the weld with the frequency of the welder. And this is starting to flatten down behind us. I still have a bit of work to do. That one there's got a little bit of a TP on it. We can work that a bit now. So my flame's gone a little bit oxidising. I'll just reset that. Now the big trick with oxyacetylene is to have your two pieces of metal butted together. So if you've got two nice straight edges, it's going to be an easy job to get the weld through. If you've got a wavy line and you've got gaps in it, you're going to be blowing holes and adding metal into it, and that's when you start having problems with it wanting to curl up behind you, buckle the panel up. Now the big thing we've got to watch on this panel is we don't want to distort the louver part of it, because nice crisp clean louver lines make a tidy looking panel. And stuff that's cooled down behind it, still got a bit of heat in there, but that's coming out pretty flat. I'll come back and weld this last little bit afterwards. It was just too hot to sort of hold on to it earlier. Actually, we can do it now. It's got an overlap on the back, which means I can't really get the dolly in there to tap it back flat. I think we'll just burn that bit together now. It's quite relaxing welding this way. You just need to be comfortable, get yourself set up. It's fairly slow, but you get a nice result, and you don't have to grind it down like you do with the MIG welds. Now, because we started out with two flat pieces of metal that butted together nicely, the only thing we've changed is we've welded it. So if we come back and our panel's got a big warp in it, the only area we need to hammer is the piece we've changed, because we know that once we take the stress out of there, the panel will sit back down to how it was before and become flat. But it's one of those jobs, sometimes you've got to read it a little bit. Some parts are best hammered while they're hot, and other parts you can just let it cool down and come back and work it with the hammer and dolly. But either way, at the end of this, we should have a nice flat panel. Yeah, my two bits of metal are a little bit out of step, just in the middle. Now we've got a little bit of a gap between the two pieces of metal here, so I'm just going to wait for it to cool down a little bit. And as I'm watching it, the little gap is just closing up between the two pieces. Need a bit of work on the end there where I welded that end piece. That'll pull out. Got a little stress line running in here, but we'll get that out of it. Okay. Don't be in too big a hurry. Once again, one piece is just sitting up a little bit. Just a matter of staying in control, getting the two edges butted together. And then flow them together. No. Says no, I don't like it.
What happened?
Just the two pieces of metal, one's gone up, one's gone down, and it's because I'm holding it with the clamp, so I'm pushing pressure on the leading edge of the bottom piece of metal, but I'm past the point where I can clamp it. So just let it cool down a bit, and I'll work the two edges flat. It's just a matter of waiting for a little bit of heat to go out. It's one of those times when it's got to be a little bit patient. But what I might do, just come back and tap some of these other spots. Like I say, we've got a stress in the corner here, that's going to need a little bit of work. Now, most of it's really flat. Got a few lumps and bumps here, and it's this little corner that's pulled it back in there. So I'll flip him over and work that out of it. Let that in cool down a little bit while we're playing with the front. On the back, first part we welded anyway. There we go, blew a little hole. Would be right at the very end. Yep. A little bit of trimming. Okay, well I declare that welded. Well, that's got that more or less finished up now. A little bit more work with the hammer and dolly. I've got a few little lumps and bumps, but they'll just tap out. But that's basically how it can be done with the oxyacetylene. It makes a nice smooth weld, a little bit of time and patience to get it all set up. At the end of the day, you've got a first-class repair. I'm Rob Teal. Thank you very much for watching.